The formula that we've seen for calculating conditional probabilities involves knowing these two items to be able to calculate this. However, one, as mentioned in the first video of this playlist, you could have the naming of the events reversed. Again, this is not a fraction, this is B given A, but notice that we see the A in the bottom here, probability of A. Same thing here. Was swapping the A's and B's over here, we would get this formula. The order of intersection doesn't matter, so we could say this instead. What matters on this one is, since it's the probability of A given B, that we'd be dividing by the probability of B. Depending on which two things you know, though, you can find the third. It doesn't matter which of these three. So quite often, we'll see something like this. The probability of the intersection would equal the probability of B given A times the probability of A, or the probability of A given B times the probability of B. So we're going to apply these four formulas in four quick examples. No particular context given to this, just some numbers given. Here we go. So first off, we've got the probability of A is 72%, and the probability of A intersect B is 43%. That would allow us, because we've got the intersection and the probability of A, to get the probability of B given A. Since we started with percents, we're going to end our answer in percents, but we're going to round to the nearest hundredth of a percent. Now, since those are both percents, this would be the same as dividing 43 by 72. This is what we get as a decimal. I'm assuming that's going to keep on going with twos forever, but whatever. If we want that to the nearest hundredth of a percent, that would be to the nearest 10,000th as a decimal. So 59.72%. Notice in this case, the probability, yeah, never mind. Okay, the second one. Now we don't have the intersection. We've got the probability of B given A and the probability of A. So we can use this formula to find out the probability of the intersection. Convert those decimals to percents to decimals. No rounding is going to be needed, because when we convert that back to a percent, we already have to the nearest hundredth of a percent. In this one, we've got the probability of the intersection and the probability of A. So that's going to allow us to get the probability of B given A. That's the first formula we saw. And when we do the division, let me show something here on the calculator. It was requested that the answer be expressed as a reduced fraction. We don't want fractions inside of fractions or decimals inside of fractions, because 0.35 is the same as 35 hundredths. 0.8 is 8/10. You wouldn't want to say 35 hundredths over 8/10 and try to visualize what that stands for. So, although I multiply top and bottom by 100 and then reduce dividing top and bottom by 5, we can just put in 0.35 divided by 0.8. And calculator now. 5, 8. Sign in there. It is as a decimal. And then if you press math, and the very first option, press enter a few times, there is our 7/16. Okay. And one more example for this particular video. Go back up. We've got the probability of B and the probability of A given B. Then we're going to be able to find the probability of the intersection. Using that formula. And if we present the decimals, then multiply. And no rounding is needed when we turn that back into a percent. It's already to the nearest hundredth of a percent. Usually probabilities go 4 places when expressed as a pure decimal. When expressed as a percent, that would be equivalent to the hundredth of a percent.